Hello, Franz here with Clay Manufacturing. In this video, we are going to create the cam toolpaths to machine the back side of our coaster. The top side, so this is our CHONK, our coaster. The top side was what we're calling OP1, and now the back side will be OP2. Right here on my screen, this is kind of a prototype I did. So I don't have one in my hand with this hat, but we started out, our initial stock was 1/2 inch thick. So it was, Z was 0.5 inches thick. And we cut it up, it was a 4-inch extrusion, we cut it at a 4-inch length. And then after we got done machining it, we're left with this hat, this extra remaining material. And so how on earth are we going to flip this thing over and put it in a machine and machine this back off? Because one of our problems was this work coordinate system was based off of the stock, and now we have precise geometry machined out. What we'll do, and is really common, is we're going to roll this thing over, so you'd put it in your vise upside down. So this is assuming you're using a standard Kurt vise where it has the standard steel hard jaws that I think are around 1.7 inch length, using the tallest parallels in a standard parallel kit. So the 1 5/8 tall I cannot talk. The 1 5/8 tall parallels in a standard Kurt vise. So you would flip this thing over. But before you would put this in a machine, is we need to go over some things. So for OP2, my work coordinate system, why is it all messed up? There we go. I don't know why I was being like that. So on my OP2, I have my Z0, the bottom face, so our machine face. And if you look, I also have our Z0 for the X and Y. They are based off a model stock point. So it's based off of our newly machined geometry. Because I don't have a good way to know the difference between this saw cut stock and our nice machined surface. So a way to do that is you get what is called a 1, 2, 3 block, and you get a work stop. So this is part of a work stop that I have. Here, I'll let you guys look at my pretty face up close and personal. So this is a work stop that would mount to like the back of your vise. So this screw actually is a screw that goes to a bracket that's mounted to the back of my Kurt vise. They make these in a lot of different shapes and flavors. I made this one. And so this stop is a stop on your X-axis. And what you do is you'll load a 1, 2, 3 block. You'll set it on the parallels. You'll touch all your tools off of the 1, 2, 3 block and then subtract your difference here. This is your Z0. And then before you actually tighten it in the vise, you had this mounted and you slid it into your stop. So that's your X reference point. So then you'll use your edge finder or your probe and you'll touch off X. And then the back of it is your Y. So you'll find your X, you'll find your Y, touch off all the tools on top of here. And then you remove this. And what you would do is you would take your other part that has the hat still on it. You would slide it against your stop because that's a known location on the X coordinate system and your Y. And all your tools are touched off on Z0, which is this face right here. And then you start machining based off, and then you can start running your program because we're going to put our WCS based off our model part geometry, so off our X, our Y, and our Z. I know that's a lot I'm throwing at you. If you don't understand it, I would recommend looking up some videos. I don't have videos like that posted right now, but it's using a work stop. Super, super common in the industry. Let's get to how we're going to set this up in our drawing where we left off. Right here, this is where we ended. This is the end of OP1 for the CHONK. And our WCS was up in this corner. So we want to continue using this stock that we've machined away, and we want to machine the rest of that stock away. And then we need to put our feet into this stock because we have a little relief right here. And then we're going to put a chamfer on it. And I just go into our drawing too. So if you go to my website, we have the CHONK drawing. And on this CHONK drawing, wait for it. Oh. We have the thickness of our part and the depth of our feet. So we have some feet back there that we need to machine out. I'm going to open mine up And I'm going to go ahead, and before I do anything, I'm just going to do a save as, so I have a new version. I'm going to call this OP2. And I do, usually in Fusion, you would just save on the same file, but I like having different starting points, especially for instructional purposes and just for references. So this is a CHONK video demo cam OP2, and OP2 is going to be our backside. Save. Now the second thing I need to do is I need to create a new setup, because if I look at this, I created it. If I look at my top of my view cube, this was my top, and I pretended I'm a 3-axis milling machine, so all my features, major features, were done from the top. Now I'm going to roll this thing over, so I'll roll it over like that, and then I'm going to change this. I'm going to still use my back corner. I'm going to use that back lower corner as my WCS location and machine the rest of this stuff away. Let's get to that. I'm going to go Setup, and I'll say New Setup. Before I do anything on here, I'm going to go over to the Stock tab, and this says from Preceding Setup, which is what I want, and then I'm going to click Continue Rest Machining. So that's looking at my prior operation stock removed. So now I'm going to go back over to Setup, and I need to open this box up so you can actually see what I'm doing. So if I click on here for the model, it already shows that it's my coaster, so that's good. Now, I don't want to do a stock box point anymore. That's referring to the actual stock, that raw stock. I want it to be a model box point, so based off of my model, because we're gonna pretend we're using these edges when we're using a the 1, 2, 3 block. So I'll say model box point, and now I'm going to define, well, I need to define my my z-axis or try to flip it. So right now, if I click on that arrowhead, I can flip my z-axis. And since it's kind of dependent on how I originally modeled my part, and how I modeled it, now my X is going right and my Y is going away from me. So that's great. Now, if you didn't model your part with the same setup origin as mine, you can go through here and define what you want as your z-axis. So if my z-axis was trying to stick out the side, then I would go here and I'd select that as my z-axis plane. And then I'd start clicking back and forth on my X and Y to get it oriented how mine is. So now I have my WCS, and in Fusion and how I'm doing it, if we need to have our X going positive and our Y going positive and our Z going positive. With this selected, I want to come over here and click on my model box point box. I'm going to come down here and grab that lower one, because I want my Z plane, my Z0, to be this surface, so this machine part I already did. And then I want this edge to be my X, because we're actually going to locate that edge on our 1, 2, 3 block with that work stop. And this edge will be our Y. So if we come off of this edge and this edge, that's right there. That's our WCS, our work coordinate system. And our Z is at the bottom. So if I look at it square from the side, my WCS is here. This yellow, don't get confused. That yellow has been machined in OP1. So we'll be resting on that face. And everything I see here is looking good. So I'm going to say OK. And you see how we have the hat now? That's from that rest machining. And now I'm going to look at some cheat sheet notes I made. For this strategy, we're just going to go straight to a machining face mill operation. And I'll let me do this. One second while I kind of get my stuff situated so I don't have to show everything on my screen right now. Let's go manage. I'm just going to my tool libraries. I'm kind of taking a look to make sure I have everything set up properly. And now we're back. If I could get my windows. All right, so there we go. For setup 2, I'm going to click on here and I'm just going to say CHONK OP2. CHONK OP2. And then I'm going to hit enter. And so now I'm going to go 2D and we're going to go face. We're going to go to my little tool library and I call it tool 1. So let's go to our clay aluminum. It's tool 1. It's our almost 2.5 inch face. So I'm going to say select. And I'm just collapsing a few windows because everything's getting crazy over here. So let's see, we're going to spin this at 6,000 RPM, 6,000 RPM, cutting feed rate. You could leave it at 30 or increase a little bit to 40. A big thing to look at is your feed per tooth. I usually falter on these kind of tools on a higher RPM, so if you get an offset wrong, it's a little bit easier on the tool and spindle of the machine. And we could run this, let's go 40 inches a minute. We'll go 40 inches a minute, so 40, 40, 40. Let's go over to our geometry. So for geometry, I'm actually not going to select anything. We're going to go over here to our heights tab, and it says bottom height is our model top. So now this is our model top. And we don't want the face mill to go past that, so that is looking golden. Shoot, this is doing it all for us. So we're going to go over to the passes tab, and I'm going to change my step over because I don't want to have a bunch of step overs. So this is how far the tool steps over. So I'm going to do 2.3 inches, so almost the diameter of my tool. We're doing, usually want to do 60 to 70%. I'm doing light cuts, because we're going to go on here and do multiple depths, and I'm going to go 40 thou, and for a finishing step I'm going to click on here. We'll put it in at 30 inches a minute, so I'll go 30 inches a minute for finished feed rate, and then our finishing step down will be 10 thou, and we're not going to leave any stock to leave, so we'll leave everything here, and I think on linking it does a pretty good job, so I'm going to leave all this here and say okay. And here you go. This is our facing tool path. So these are our 40 thou step downs, and then this little blue line right here is our 10 thou finished step. So you could click on here and then go action simulate, and then run it through here. Also, don't pay attention that the fact that I don't have a tool holder on here. Yeah, you get what you pay for, huh? And that's just going to do several steps and cut that all off. So now we have the thickness to our nominal dimension. And having Z at the bottom is super easy to hit your values plus or minus a thou for your nominal dimension, because our Z0 is referenced at the bottom, so we're basically just approaching down. Where if your Z was off the top of the part, you'd have to get a real exact measurement of this, and extrusions aren't perfect. They're not, it's not going to be ½ inch exact. It's usually a little bit over. With that said, we will move on to our next tool path. And now with this done, I want to hog out the center of this, and we're going to use a 2D adaptive. We're going to go 2D adaptive clearing. That's our roughing strategy. So I'm not going to rough with this guy. I'm going to get a 3/8 flat end mill. I'm going to go clay mini mill aluminum, and it's my T2 3/8 flat end mill. I'll say select. We're going to run it at 6,000 RPM. That's the max my spindle will go on a mini mill. And then I'm going to run it pretty fast. We're going to go at 50 inches a minute. I mean, it's not that fast. We're going to go 50 inches a minute and 50, 50, 50. And when calculating your feeds and speed is really determined by your chip load. All major tool manufacturers have charts on their recommended chip load, and the smaller machine you have, you really got to start going down, and you might not even be able to run their recommended chip load or feed per tooth. Next one, we are going to geometry, and I don't think I'm going to select anything. Actually, I am. I lied. I'm going to, you see how I'm highlighting this? I'm not selecting under there where I'm grabbing a line, but I'm highlighting this. I'm going to click on there. And that looks pretty good. So that blue is where it should machine. Let's go to my heights tab. Bottom height is the selected contour, which I just did, so that's good. Passes tab. I'm going to increase my optimal load, so that's kind of your step over, to 0.0375. A good rule of thumb is 10% of your cutter diameter, so 0.1 times 0.375 is 0.375. Super easy math. We'll leave this stock to leave. I'm going to leave radial and axial, so under the tool and on the side of the tool, because I want to come back and do a finishing tool path, because this is going to leave it's going to leave some marks on the sidewall, and since I'm going kind of fast, it might give me little chatter marks under the tool. So we're just going to go 10 thou, 10 thou. I always like to run smoothing. I always like to run feed optimization. On this one, we'll leave the defaults. Linking, we should be okay over here. Let's hit OK and see what our toolpath looks like. Brilliant. So that's looking pretty good. And I'm just going to hit save so I don't lose any information. Okay. Oh shoot, we're already 15 minutes in this. We only have a few more toolpaths. Now we're going to come in there and clean it up. So one of my favorite go-to strategies is a 3D horizontal. We will use the same tool. So that's going to be, from my library, it's our T2 3/8 select. And we have 6,000 RPM, 6,000 RPM. We'll go 40 inches a minute. We'll go 40. Arrow. My dog, it's raining outside and my dog is chewing on her little paw. 40, 40, 40. Let's go to geometry tab. So chain, I'm going to come in here and I'm going to do the same thing. I'm going to try to like select. How do I do that? So let's go, oh, because I had none, that's why. I need to go to selection. And then I'll try to click on this inside. Let's see if I screwed up again. How come it won't? I don't, let's see, deselect. Oh, you know what? I think I have to do this. So I'm gonna select that bottom one. We're gonna leave these defaults right here. And what we need to be careful with is our height. So on our heights tab, for our bottom height, I'm going to go selection, and I'm going to say that face is my bottom. So I don't want my tool to go further than that face. And on this one, check it out. I'm going to go model top, and I'm probably going to have to come back here and fix it. So if I go model top and say OK, oh no, I didn't have to cheat it. So I did model top, so I recognize that's my top, already machined, came in here, and this is going to be a finished toolpath to remove that adaptive from this toolpath right here. So this is a kind of finishing strategy, and it's 3D, so it recognizes three-dimensional geometry. And I'm just going to double check my feeds and speeds. It all looks good. I'm going to say, oh, I like to do smoothing. Let's turn on smoothing, and we'll just click feed optimization for fun, and I'm going to say OK. And there's a little feed optimization right here in this corner. You can see that yellow. And I'm going to hit save so I don't lose any data. Oh, we are looking good. The next thing that is left is really just to add a chamfer to this bad boy. So I'm going to go 2D. And I will say chamfer. And you notice I don't like to model my chamfers because a lot of times it's annoying when you're trying to select geometry and faces and stuff. And so this went ahead and defaulted to my, let's go to my library and make sure I didn't get a wrong one. We're going to go mini mill aluminum. What is my chamfer? T5. So I wrote my note wrong. So this is our T5. We'll say select. And we're going to go 6,000 RPM. I'll just put that one at 6,000 RPM. We'll go at 30 inches a minute. 30, 30, 30. And it is time for our geometry tab. So I'm going to come in here and I need to select all 4 of these edges. Be careful you're not selecting the bottom. And then I'll go click. And I want to do the tops of these feet. And that's looking okay. We'll go to heights tab. I'm just confirming bottom height is selected contours, so that's all good. Passes, I like to do a nice light chamfer width of 10 thou. Now, if you're using chamfer tips that look like they're chipped, they don't come to a nice sharp point and they're chipped, they're going to bury that chamfer. It's going to be a lot deeper than what you're telling it right here because you're actually burying it further up the diameter of the tool. So this is calculating where it should be based on a perfect chamfer tip. We're going to leave a 40 thou offset. Boom. We're going to do smoothing, feed optimization. That's looking good. Now let's come over here to linking. I like to always do a lead-in radius so it's a nice smooth transition. So I'm going to go 50 thou, sweep angle 90. I'm going to lead-in distance, I don't need that. We're going to go 0. And vertical lead-in radius, we're going to say 0.0. I'm going to say OK. It's looking good. I like it. And you see it automatically selected to go to radius in on these corners, which I like. And this, let's see. This gray, if you see how it does the gray, that's where it machines into your geometry, which is what we want on a chamfer. So this is something to note where if I did a horizontal and I saw big gray in here, it means it's plunging in my part. So it's something to pay attention for. I'm going to save this so I don't lose any data. So this, my friends, this concludes the toolpaths for the CHONK. And here we go. So we have our top operations, and then we have our back operations. I got some Sharpie on here because I was where is it? I was doing some prototyping with my tool offsets, but that's kind of what it should look like. And you should have nice chamfers that walk around all your part. Hope this video is helpful. Have a good one. Bye.